In pursuit of sharing technical knowledge and just to gear up the new generation of engineers, myself Pranab is here to deliver today's presentation, Power Transformer Part 24. As the topic is of the continuation, so for your convenience, the link of the previous one is given under the description box. Let's start with main constructional features of large power transformers. Capacity of the conservator tank would have to be designed with the consideration that the transformer must be able to cater the specified overload without overflowing of oil. As per IEC, the conservator design should be implemented by considering the oil level increment with the temperature ranging from minus 25 degrees centigrade to plus 110 degrees centigrade. As a normal structure, it is conventional that the conservator must be erected on the left side of the transformer main tank while viewing from HV side. The conservator should have to be equipped with air cell type construction so as to maintain constant oil pressure system with having an excellent barrier of contact of moisture and oil, and thus possibility of oxidation and hydrolysis of the oil can be readily restricted. Air cell must be of flexible type and are highly applicable for protecting fluid in transformer against the atmosphere without affecting the operational function of the system. Inflatable air cell is made of high temperature resistant, that is 130 degrees centigrade at least, NBR material, nitrile butadiene rubber, reinforced with highly oil resistant nylon, that is polyamide fabric coated on both sides and acts as a flexible separator while fitted inside the conservator reservoir. Outside wall of the conservator tank must be written with bold letters, caution, air cell fitted. The transformer rating and diagram plate must be depicted also by a warning statement that the main conservator is fitted with air cell. The maintenance wing must have to follow the visual as well as usual norms as applicable for requisite protection and caution while attending any trouble in air cell fitted conservator. Again, I repeat, the maintenance wing must have to follow the usual norms as applicable for requisite protection and caution while attending any trouble in air cell fitted conservator. The operation, maintenance, testing and replacement of the air cell must have to follow very judiciously as per the OEM, that is original equipment manufacturer manual. Manual has to indicate the durability and working ability of the air cell, life expectancy in operation, and the recommended replacement intervals. Conservator shall be configured with magnetic oil level gauge with potential free high and low level alarm contacts and prismatic oil level gauge. However, gauges must have to be monitored and mounted in such a way with slightly tilted downwards by an angle 10 degree to 15 degree so as to view the ratings and readings of the conservator tank from plinth level. Again, I repeat, however, gauges must have to be mounted in a way with slightly tilted downwards by an angle of 10 degree to 15 degree so as to view the readings from plinth level. Buchholz relay, which is a type of gas detection relay, must be installed in connecting pipeline from main tank to conservator at an angle of not less than 3 degree rise towards the oil conservator end. Minimum diameter of 25 millimeter pipeline as connected to dehydrating silica gel filter breathers of adequate size must be fitted to a point in the oil conservator tank not less than 50 millimeter above the maximum working oil level. For 220 kV and above voltage class of transformer, there would have been recommended for installing 3 numbers of identical size dehydrating silica gel filter breather connected in series for main tank conservator. In case of less than 220 kV class of transformer, it is recommended for installing 2 numbers of identical size dehydrating silica gel filter breather connected in series for main tank conservator. Power transformers as of industrial applications are mostly equipped with on-load tap changers, that is OLTCs. Normally, 2 types of switching principles that would have been used for load transfer operation. One, high-speed resistor type OLTC, and number 2, reactor type OLTCs. However, most of the resistor type OLTCs are installed within the transformer tank, that is in tank, within the transformer tank, that is another separate tank OLTCs for OLTCs, whereas the reactor type OLTCs are configured in a separate equipment and separate compartment rather, which is normally welded to the transformer tank. Again, I repeat, most of the resistor type OLTCs are installed within the transformer tank, that is in tank OLTCs, whereas the reactor type OLTCs are configured in a separate compartment which is normally welded to the transformer tank. As the reactor type OLTC is kept in a separate compartment, so the oil of the load tap changer always be isolated from the main oil tank of the transformer. If the load tap changer has its own oil conservator, conventional type, then the breather and the oil level indicator emoji on the conservator must have to be incorporated as well. For the conservator as meant for OLTC, it is recommended for installing 2 numbers of identical size dehydrating silica gel filter breather connected in series. To have a safe operation of the load tap changer, the dielectric strength of the corresponding oil must not be allowed to be less than 120 kV per centimeter. Transformer tank. The transformer tank is totally leakage proof container which is meant for accommodating a specified space for holding core and winding with their supporting structures and be a safest containment for the dielectric fluid. As the filling of dielectric fluid into the tank should be made under a high vacuum condition, so the tank must have to act as the vacuum vessel for this operation. Mostly, transformer tanks are constructed by welded boiler plate of BS 4630. Tank also can be fabricated from tested quality low carbon steel of adequate thickness and the metal plate bar sections for fabrication shall have to comply with IS 2062. In 1960s, as corresponds to road transport weight limitations, transformer manufacturer in UK had impressed in designing and to construct tank of large transformers with aluminum as a base material. Each tank base shall be so designed that there would have been made possible to move the complete transformer unit by skidding in any direction without being damaged. Base plate shall have the following minimum thickness as corresponds to length of the tank. Length of the tank over 2.5 meter but less than 5 meter. Minimum plate thickness should be 20 millimeter. Over 5 meter but less than 7.5 meter, 26 millimeter thickness. Over 7.5 millimeter, then the thickness will be, minimum thickness will be 32 millimeter. Tank cover and associated structure should be adequately designed so as to withstand severe strains that may be induced under the undesirable factors during lifting, jacking, and pulling at the time of transportation, shifting, and handling at site. At the same time, these items must be capable of withstanding the specified test pressures, vacuum, seismic conditions, and short circuit forces. Removable cover plate over the tank should be configured in such a way that easy access can be obtained for installation and future removal, if necessary, of core and windings. The cover is normally the simplest of fabrications, often no more than a stiffened flat plate and to be fitted with an inclination to the horizontal at about 1 degree so as to prevent from retention of water. Welding that applicable for plates and structural members during tank fabrication shall have to conform to IS 9595. The requirement of post-weld heat treatment of tank and stress relieving shall be based on recommendation of IS 10801. After placement of the transformer active part, that is core and winding, with their associated structural components, an adequate free space at the bottom section of the tank must be provided for having collection of any sort of sedimentation. Provision of certain number of pockets at suitable locations are to be configured on the tank cover for inserting the probes for oil and winding temperature indicators. So, packets for OTI, WTI, and RTDs, including 2 spare pockets, should therefore be provided in the specified positions of the tank. Locations must have to be precise that the replacement of damaged probes of OTI, WTI, RTDs can be easily made through without lowering the tank oil level. The thermometer would have to be fitted with a captive screw so as to prevent the ingress of water. Cover plate is also comprised of adequate number of small removable covers allowing access to lower end of bushing connections, winding temperature cities, core earthing links, off-circuit tapping links, and the rear of tapping selector switches. Inspection covers should be kept to a minimum as because all the gasket joints, including the main cover flange, will be the most potential source of oil leakage. The tank cover flange, since being of large cross section, it tends to provide a path for leakage flux with the resultant eddy current heating leading to overheating and degradation of gaskets. Different types of rubberized cork gaskets and O-rings are therefore to be used during manufacturing stage, and the basic problem of oil leakage from transformer bushings and covers are instigated mainly due to use of non-standard or non-specified gaskets of or O-rings during assembly. Another point to be noted, inferior quality and improper fitment of gaskets is just to be rather undesirable because of various long-term adverse effects on dielectric integrity of the transformer components. Cork composition sheets for gasket are made by the compounding of granular cork with natural or synthetic rubber. There are three types of cork sheet. Type A, non-oil resistant. Type B, good resistance to oil. Type C, suitable in electrical industry with excellent resistance to oils and petrol. Cork sheet as used must be free from cracks or pinholes and would be capable of being cut or punched without cracking or tearing. Cork composition sheet is not recommended for storage under conditions of higher degree of temperature, humidity, or for reasonable period of time, as because sheets are likely to cause deterioration over time. However, before being put into service, many rubberized cork products and components are to be stored in conditions for a period till no unwanted changes in their properties. As per IAS 4253 Part 2, 2008, the rubberized cork sheet gaskets and O-rings would have to be stored preferably in a dark place, that is to be kept away from direct sunlight and at the regulated temperature of 27 degrees centigrade plus minus 2 degrees centigrade with relative humidity in the order of 65% plus minus 2%. Criteria of using gasket for tank and its cover. Based on the temperature conditions as well as environmental factors, all sorts of gasketed joints for tank and cover shall have to be precisely designed, manufactured, and thus to be assembled to ensure long-term leak-proof and maintenance-free operation. All gaskets or O-rings should be made of NBR, that is acrylonitrile butadiene rubber, which exhibits excellent resistance to acids, alkalis, gasoline, hydraulic fluids, and petroleum-based compounds. NBR has the property to withstand temperature ranges from minus 40 degrees centigrade to plus 100 degrees centigrade, which is rather suitable for transformer tank and cover gasketing. Depending upon the service conditions and mode of applications, vulcanized rubber gaskets are specially available in 4 different types, and each type is divided into a number of classes which having different hardness. Type 1, general purpose of gaskets having superior physical properties. Type 2, general purpose gaskets having moderately good physical properties. Type 3, oil resistant gaskets suitable for lubricating oil and petrol. Type 4, heat and oil resistant gaskets. Gasket dimensions at the mating surfaces of tank and cover should be adapted to ensure leak-proof joints at extreme conditions. NBR is an excellent durable elastic material which will sustain certain variable pressure applied on it and has to create an impervious seal that would have been enhanced to strengthen in direct proportion to the force exerted upon it. Unlike other gasket types, as the NBR material has an unique microstructure, so NBR gasket is rather suitably attributed to its elastomeric nature for mechanically sealing the microscopic gap between two mating surfaces or joints. The gasket material and additives should be fully compatible with transformer insulating fluid or oil and would have to resist all kinds of chemical and environmental attacks. The gaskets should possess with a very stable material and of course should not contain oil soluble sulfur compounds. The properties of all the gaskets or O-rings shall have to comply with the requirements of type 4 rubber of IS 11149. Gasket fabricators are made to match the geometry of the mating surfaces through typically machined by computer-aided manufacturing, that is CAM techniques, which ensure the precision of the profile. Gaskets and O-rings shall be replaced every time whenever the joints are opened. Large size removable covers which are to be made for adequate safe access should be fitted with proper gaskets and sealing compounds so as to withstand requisite vacuum and pressure conditions and enable them to be handled safely by the maintenance personnel on site. For safe handling, it is recommended that each of the inspection covering plate should be of bolted type and weigh not more than 25 kg. Design capability is always to be entertained when the tank would have to sustain for a considerable time period under the full vacuum condition. Basically, stiffness and vacuum withstand capability test usually involves subjecting the tank of any new design which has to be kept for at least 2 hours of time to a specified vacuum when tank is in empty of oil, and then have to measure the permanent deformation remaining after the vacuum has been released. After release of the vacuum, the permanent deflection of the tank sides should not exceed specified limits depending on length. Up to 132 kV voltage class, transformer tank would have to undergo a vacuum equivalent of usually specified to 330 M bar absolute pressure, that is 0.325684578016 atm, that is 4.78 psi. For 275 kV and above voltage class, transformer tank would have to undergo a vacuum equivalent of usually specified to 250 MVAR absolute, that is 3.63 psi. Atmospheric pressure equals to 1.013 bar equals to 1013 millibars M bar. Both cases, tank vacuum is indeed being held up to 2 hours of time, and maximum allowable permanent deflection limit should be up to 13 millimeter. For the purpose of checking mechanical withstand capability of the tank, a pressure equivalent to 3 M bar absolute should be applied for 8 hours of time. All tanks must entertain leak tightness checking by filling with a fluid of lower viscosity than that of transformer oil, usually white spirit, and then applying pressure of 700 M bar or the normal pressure plus 350 M bar, whichever be the greater, for 24 hours. The tank wall stiffness, that is, the tank wall stiffeners are so designed that the walls must be braced to withstand full vacuum as well as pressure 25% greater than achieved during normal operating condition of the transformer. Minimum 4 symmetrically placed lifting lugs of adequate size shall be provided for the purpose of lifting the complete transformer filled with oil without any structural damage of the transformer. However, the factor of safety of each lug shall not be less than 2. Suitable haulage holes shall be provided for shifting and dragging of the complete transformer filled with oil. Minimum 4 jacking pads would have to be provided in accessible position so as to raise or lower the transformer at oil-filled condition by using hydraulic jacks. Let's stop here, further to be continued at later stage. Thank you for listening the video. Kindly do like, share and subscribe. Your subscriptions would encourage to post more videos. Also share your comments or feedbacks inside the dedicated comment section. If you have any suggestions or specific topic you want, then let me know in the comment section, please. Thank you. Thank you for patient hearing.